Hello and welcome to Engineering Thoughts, where engineering minds come together to discuss topics of relevance and interest to our industry. I am Vanessa Sealy-Fisher and today I'm joined by Coenie van Eck. Coenie is a professional civil engineer with over 20 years of experience in bulk water infrastructure across Southern Africa. He's currently a business unit manager at Bigen, where he is leading large-scale projects involving hydraulic design, surge analysis, and the implementation of major water supply systems. Coenie's expertise spans the full project lifecycle, from feasibility studies and detailed design to contract administration and construction management. His work has included major pipelines, pump stations, and reservoir projects throughout Southern Africa, including Botswana, with a focus on technical excellence and client collaboration. Welcome, Coenie. We're delighted to have you join us today.
Thank you very much, Vanessa.
Now, before we get into some of the nitty-gritty of civil engineering, I'd love to know how your engineering journey started. What sparked your interest?
Well, since I was small, my dad is a structural engineer,
Right.
And I always found it interesting, the work that he brought home, more structurally related projects where you have nothing the first day and by the end of the project there's a building standing.
Yeah.
So that really sparked my interest, and I think from there it grew. And throughout school I liked the technical side of things, and that just developed the love for it, and I moved forward from there.
Now, you studied civil engineering, and that's quite a broad discipline. How did you hone your skills and your focus to the pipeline sector, and in particular with hydraulic analysis?
So I got a bursary at the Department of Water Affairs, and that kind of forced me into pipelines. When I finished my studies, I started there and I worked there for 3 years. And from there, it just grew and I kind of liked it. I love the fact that you can design the pipe and, you supply water to people. Yeah, and looking back, I'm very happy that everything started there, and I'm very happy with where I am at the moment. Yeah, so now I'm grateful for the department.
So you've actually alluded to something that is of interest to me, is in a big picture way, how do you design a pipeline from scratch to water in my home?
So it takes we normally get a project from a feasibility phase where the client already came to the party and said, listen, I need water to this or that area. Some feasibility studies were done and then determining the demand to that area.
Right.
Then from there, our main focus is pipelines. So we will find a pipeline route and then size the pipe accordingly, do the environmental and all the related studies which needs to be in place before you can go onto construction. And then we do the hydraulic design, check that, like I said, your pipe diameter is large enough, the route is finalized, and you do your chambers and so forth. And yeah.
Okay, now in terms of this hydraulic design, in my head, hydraulic water design of water or water systems, big picture, because I don't understand the maths, how do you facilitate that? What are you looking at when you're doing this hydraulic design? Is that based on the volume of water you need at the output end, or what determines it? And I've also heard of surge analysis. How does that tie in?
So basically, the demand is how much water you need, and that will determine the size of your pipe. The longer your pipe is, the larger diameter you'll need, because you have friction in your pipe, which kind of reduces the pressure at the end of the line. A gravity line and a pump line operates basically the same hydraulics, but you also have to take into account the friction losses. And then from there, that determines the diameter of your pipe. So surge analysis and a surge wave is basically when you have a sudden closure of a valve, and that spikes the pressure inside the pipe, and that can cause significantly higher pressures in your pipe than what is under normal operating conditions. So that's why it needs to be taken into consideration.
And would that then determine the steel thickness that you choose, those kinds of parameters as well?
Yes, definitely. So in terms of the steel thickness, it's your internal pressure plays an important role, and then also your external pressures. So depending on the depth of your pipe, what vehicle loads they'll be on, and also the bedding around your pipe. It all plays a role in finalizing the wall thickness of your pipe itself.
So pipe isn't just a pipe, it's part of its environment, actually, to get it through. That's so interesting. Now, I know that you've been involved in projects that are almost exclusively urban and cross-country pipelines, which one could term as rural. Are there any significant differences between them from the design perspective that come into play?
So, in my view, there's not a big difference between a small rural project and a large pipeline. The hydraulics will remain the same. Your parameters will maybe differ in terms of your flow and your pipe diameter, but the hydraulics remain the same. Also, your operating conditions may differ slightly, where a rural pipeline will probably have house connections, which impacts the hydraulics and the flows. And your bulk water pipelines normally goes from a pump station to a reservoir, so it's a little bit more controlled. In my view, that's the biggest difference, but the hydraulics are the hydraulics. So
That's interesting.
the same.
Now, through your career, you've been involved in projects kind of from birth to the final covering of a pipe. I don't want to say the grave because that's not what we're looking for. But in terms of the feasibility studies and construction, do you have a favorite part of the process that you enjoy most or one you enjoy least?
So for me, the detailed design is the best part. That's where you really put your knowledge and your experience into play. You also have to take practical considerations. Keep it in mind in terms of your chambers that you need to design, in terms of your layouts. And that's a part I enjoy the most. I'll rather not go into what part I enjoy the least. But yeah, the detailed design is the favorite.
Now, a lot of the projects you're involved in actually require strong collaboration between local authorities, stakeholders, and obviously the players during construction. How do you manage that process, building trust, ensuring alignment between all the parties?
Yeah, so I think nowadays most of the projects have that challenge. Fortunately, in the bigger projects, we have social experts, specialists that we involve. But on the smaller projects, you know, a lot of times we as engineers have to go to the communities and explain the impact of the project. In my view, clear communication is the most important thing. You know, these people depend on you for water supply in most cases, and also for jobs. And that's a very scarce commodity at the moment in our country. So clear communication of what is expected, managing those expectations, and especially on larger projects, the people want job opportunities and they see big contractors coming in and they think everyone in the whole community is going to have a job, and that you have to manage that, and you have to communicate clearly of what will be available, what jobs will be available, what water will be available at the end of the project. So communication, in my view, is the most important thing.
Yes. And when one studies engineering, you don't think that actually the biggest skill you actually need to develop is communication.
Absolutely.
It's quite a challenge. You've worked across so many areas of our country throughout, including Botswana. What do you think has been the most technically challenging project? And aligned with that, how have you overcome the challenges?
Yeah, so I can't really highlight a single challenge that I think this is the most technical challenging project I have had, because every project to me has got some technical issue that you need to resolve. But the way in which I resolve it is normally with a strong team. We have a very strong team on my side, and you can always go to someone that you can, even if you just bounce an idea from that person, that's important. But in our team, there's always someone that's hydraulically stronger than you, or they have more experience than you. And to me, is we group together, we work as a team, and to find the best solution. And that's important to me. I don't think if I was a single engineer, then half the project would come off the ground. But it's normally the collaboration. You learn from this guy and you learn from that guy, and then you find a solution to the problem that you have.
That's encouraging to hear, that engineering really is this collaborative teamwork, almost a mini societal construct. Yes. Have you ever experienced a project that has completely changed the way you think as an engineer?
Yes. So when I started at Water Affairs, I started with large diameter pipelines, and then in my career I moved to Bigen, and then one of my first projects that I could run on my own was a small rural distribution system that I had to design. And it just opened my eyes to what we're really doing, because you know, we normally, in my day-to-day job, you take bulk water and you design a large diameter pipeline and it goes to a reservoir, and then someone else takes it from the reservoir to the community. And this was really an eye-opener to me, to just be aware of what we're really doing. You know, people that don't have to walk kilometers for water now can, at that stage it was just stand taps. So it's 100 or 200 meters that they had to walk. But just to give them access to water was an amazing it kind of changed the way I looked at my day-to-day job, where you don't just go in and design a pipeline, but you actually give people water and ease their lives. So
Positively benefiting lives.
Correct, yeah.
Yes, that is very fulfilling. Moving back to the concept of challenges on a day-to-day basis, what do you think are some of the biggest challenges facing engineers today?
I think in our setup as we have it currently in the country, I think operation and maintenance is a big challenge. I don't know if there's always the budget in the municipal infrastructure or the funding to operate and maintain infrastructure. So there's a lot of funding options, avenues you can get for bulk water funding, for bulk infrastructure. But the funding of the operation and maintenance is, at the end of the day, where I think one of our biggest challenges lie. You can construct a 5 or a 10 megaliter reservoir and a water treatment works, but if there's no operation and maintenance, then there's no water. And that's with the whole system. You'll know the cathodic protection system. If it's not maintained, then in 5 or 10 years' time, there's nothing left of the pipeline. So I think that's one of the major challenges. And then also, lack of expertise at certain levels of municipalities and in the clients. So I think we're lacking some technical skills just to understand the project, understand the impact, and then, so those two are what I think is the biggest challenges.
Yes, and they are. And we're seeing an influx of artificial intelligence now throughout society. It's obviously impacting engineering. Do you see it playing a role at the moment? Do you see its role increasing, decreasing? Are you concerned about AI?
Not at the moment. At the moment, I'm not concerned about it. I think it's going to start playing a bigger role in the industry. At the moment, I see it as a tool. At one stage we had drafting people, and when we moved to CAD operated software, all the drafting people were concerned, and it just caused them to up their skills, change maybe the approach, and then work from there. And I think AI, I don't think it will ever replace fully the engineering industry, simply because the challenges differ from project to project. There are no two projects that are the same in every aspect. So although it can address most of the challenges, you always need a person who understands the basics and the background to address and to interpret the information that the AI produces. So in my view, it's a good tool to have, and I think the companies that can harness it and develop it and use it to their advantage are the companies that are going to move forward and not stay behind and get stuck.
Interesting, thank you. Yes. So there's a group of young engineers now perhaps wanting to enter the field. As we close off, what advice would you give them looking back over your career and them starting out? How could they optimize what they are exposed to and experience?
In my view, take responsibility. When you get a task to do, understand the bigger picture, and also understand that there's a process. You can't start by designing a 20-kilometer pipe if you haven't done a 1-kilometer pipe. The basics, like I mentioned, remain the same in terms of the hydraulics. So understand the process, understand that it takes time to get to where you want to be, and take responsibility for each task that you do. From a managerial point of view, it's always good if a young engineer can come back to me and say, listen, I did this, where do you see the problems? Or where do you see my mistakes? Rather than, here's what I've done, now you sort it out. So you have to take responsibility and have a good attitude from the start.
Great. Well, thank you. Coenie, thank you so much. This has been so interesting, getting to grips a little bit with what I've always looked at as this very big unknown called civil engineering, and never quite sure. So thank you for taking time to come and chat with us about your own experiences and sharing with us a little bit more about pipeline engineering and the water supply industry. So thank you.
Yes, pleasure.
And thank you too for tuning into this episode today. I do hope that you found our Engineering Thoughts episode today interesting and stimulating, and that you don't forget to subscribe and to turn on notifications to ensure that you don't miss another video. We'll see you next time, and until then, stay curious.